All right, so taking a look at another sapling type question. It says, draw the main organic products of the reaction. Indicate the stereochemistry including all hydrogen atoms at each stereocenter. Omit byproducts such as salts or methanol. Okay, so for this one, again, first thing we identify is what type of alkyl halide do we have. So you can write, we'll do E1, E2, Sn1, Sn2. What type of alkyl halide do we have? Primary, secondary, tertiary, allylic, benzylic, lone pairs. What kind do we have? Secondary. Does that eliminate any possibilities? No. Darn it. Okay, so then we look at the nucleophile. Is it reactive? Yes. So remember, this is really this. All right, that nucleophile is pretty reactive. It has a negative charge. Does that eliminate anything? Limits E1 and Sn1. Right, the ones with carbocations. If we have a negative charged species, we're not going to make a carbocation. So down to E2 and Sn2. If we have a negative charged thing, we're never going to do Sn1 or E1. Right? So now we're down to E2 and Sn2. And honestly, it's going to be both. And they want both. Right? So they want both products. So let's do both. Which one do you want to do first? E1 or you want to do E2 or Sn2 first? Let's do E2 first because it's there. Right? So we'll really have to redraw this twice. So let's do we'll do the E2 one first. So E2 is coming out first. So doing E2, we need to find the leaving group, right? So let's number these carbons. 1, 2, 3, 4, 5, 6. We want to find the beta hydrogens. All right, so we numbered our carbons, which you all should do. So we're looking for beta hydrogens for E2. So beta from carbon 2. How many different types of beta hydrogens are there? 2. There's one on carbon. Which carbons have beta hydrogens? 1 and 3, right? And which one are we going to take? 1 or 3? Got to be careful. We got to make sure. We want to make the Zaitsev product, but we got to make sure that they're anti-periplanar to each other. They have to be on opposite sides. I still like this one. This is still the best one to take. Why? Well, it leads to the most substituted alkene, the Zaitsev product. And the H and the bromine, this is wedged, that's hatched. That means they're anti-periplanar to each other. They're opposite sides of the ring, right? They got to be on opposite sides of the ring, otherwise they won't react. If they're not opposite, it won't work. E2 reaction. What's our product going to look like? Get a new pi bond between which two carbons? 1 and 2. So that there. 1, 2, 3, 4, 5, 6. E2 product. Zaitsev product. Most substituted product. So now to do the second part of this, we needed to do the Sn2 reaction. Right, so the Sn2 reaction, so we needed to do the find the reaction with sigma star, which is on the opposite side. So the bromine is wedged here. Sigma star would be hatched to be the opposite side there. So again, one-step reaction. Nucleophile comes to the back side, pushes that out. What's going to happen to that stereocenter? So nothing happens to this one. Nothing changed there. And what was hatched now becomes wedged, and the nucleophile has gone to the back side. That's the Sn2. So you've inverted this stereocenter when we talked about 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right, so again, now how do we identify stereocenters? Has to be sp3 hybridized and bonded to 4 different things. This is carbon 2 and carbon 1 are actually bonded to 2 different things, or all bonded to 4 different things, so they're both stereocenters, 1 and 2. So what did you make here? If I showed, if this was A and this is B, what are they to each other? What kind of relationship do they have to each other? They're diastereomers. All right, they're diastereomers. How do I know they're diastereomers? This asymmetric center on carbon 1 stayed the same. I don't even know if it's RS. I know it didn't change, right? And I know carbon's 2 stereocenter, asymmetric center did change. So these two, A and B to each other, they're diastereomers. They have the different physical properties, right? Have at least one asymmetric center that's different, one that's the same.